Okay, you guys, let's be quiet really quick because a lot of people had questions on number 5 on page 2. So let's do it together really quick, okay? I'll write it out. Okay, ready guys? Let's be quiet really quick so we can show everybody how to do this one. Yeah, number 5 on page 2. Okay, so the first way we do it, way number 1, they want us to add and subtract the things that are in the parentheses. So what's 10 minus 3? 7 plus 2? 9. What's 4 times 9? 36. Thank you. Can you guys be quiet really quick so we can do this? Yes. Thank you. Okay, so for this one, the way they want you to do it is break it down. So it's like 4 times 10, 4 times 3, 4 plus 2. And I'll show you where some people got confused. So what's 4 times 10?
40.
40. What's 4 times 3? 12. What's 4 times 2? 8. So, see, this is the part where people got confused. We're going to add the subtract, like we're going to subtract these. But for this one, we're adding right here, these two numbers, because this one is addition. Does that make sense?
Yeah.
So what's 40 minus 12?
28.
38. 28. Sorry. Plus 8?
36.
36. Does that make sense? We didn't really do an example like that with the two different things, but makes sense? We got it? Okay, let's work on it.
Give me my pen. The 7 right here.
Yeah, you put the 7 there because it's breaking the equation down.
9.
And then you put 9 down here.
So I think for this front page, I don't think you have to show your answer. I think you're just breaking it apart.
Okay, I'm not showing no answer.
Do you see what I'm saying? Those boxes, they don't give you an answer box, but they're giving you boxes to break the thing down.
Wait, so I put 12 here and 5? Since it's 5 times 6.
Yeah,
Oh.
good job.
I'm already halfway done.
Wait, is it 7?
Good job, Liam.
Is it 7? I'm not really sure.
7. 7 times 4 and 7 times 8. Yep, good job. 7 times 3, 2. Yep. Ooh, that one's a little trickier. You guys at number 6?
I did
Yeah,
number
I'm at
6.
number
I passed
6.
number 6.
Okay, let's look at it. So, we see that there's a 5 there. And we see that this number is in both of the equations. So that would be the number that's here. It would be 6. Does that make sense?
Yeah. And then this one right here.
3. Yeah, good job.
So this one right here.
So let's look at it. We see an 8, but that's a little confusing because there's both 8s there. That would be an 8. Yeah? And then a 3. Yeah.
You want the answer? Or you
Yeah.
No. So here,
What
5
number are
times
you?
7.
Yeah.
What number are you? Like number. And this is a 9. Oh, I thought you were number.
That's a 9.
Your computer's turning off.
And that one 10, so we would put a 2 there. Right? Good job.
Here.
Not a 2, because the 2's already there.
So it would be 15.
Good job.
Here. 4.
9.
9. Wait.
Not 9. 4. Yep, good job.
A mess.
Yeah.
Uh-huh.
Okay, do you guys want to work on this page together?
Yeah.
Yeah? It'd probably be easier. Because we really need to show our work and break it down. That's how we're going to get points on this assignment.
I just do PEMDAS. Would you be mad if I drew on the table?
Yeah, don't do that, please.
You can get the 10.
Okay, let's work on it together. Ready?
Yeah.
Bella, are you ready?
Yes.
Okay. So how would we do this first? What would we start with?
3 to 7 is 20.
3 times 7.
Plus 5?
No, wait, to add the
3
5.
times 5 is
3 times 5 is,
15.
then add those together. What'd you guys get?
36.
36? Did you guys all get that?
No. Wait,
No, I got 27.
You want to sit over here, Bella?
Yes, hold on.
Gonna help you.
Oh, I got it wrong.
You got it
I
wrong?
mixed 2 and 1. So I put 12.
You sit here, Bella.
Yeah, I got 36.
Okay. Let's do the other part of number 2 together. So what we're gonna do, 3 times 7, what's that?
That's the same.
Think about it. 3 times 7, what's 2 times 7? 14?
21.
21, yeah, good job. So 21 right here. So break it down and write 3 times 7 is 21.
And then is it the exact thing? Or
And then 3 times 5.
is 15?
Oh.
So we'll probably have to
Oh,
do it.
I was doing it wrong. Oh my gosh, teacher mistake. Sorry. Oh, I can erase that. I didn't see that. Okay, so what we're doing for this, yeah, me either. The way 2 is the way we're breaking it down. Good. Is we're gonna do, like, write it out. So it says 3 times 7 plus 5. So what we're gonna do first is write 3 times 7 plus 3 times 5. We were already kind of doing that before
But can't you
because
just,
we were showing our work. But I think that's how they want us to show our work.
but can't you just do 7 plus 5 and then times it by 3?
Yeah, but they kind of want you to, like, break it down, show all your work.
Look, so this part is for this one.
Yeah. Yeah, so that's what we're doing. So what's 3 times 7?
3 times
21.
21. What's 3 times 5?
15.
15. Add those together.
Oh, 36.
36. Yep, so you're getting the same answer on both sides of it, but it's just showing you, like, different ways to do it. This one you're breaking down more. Does that make sense, Liam?
3 times
Yep.
7.
that.
Okay. You work on this, Bella?
Oh, plus 3 times 5.
We'll see. Liam, you want some help?
I'm good.
10 times
Got
12 is
it?
120, right?
Okay, do number 3, you guys, together as a group.
Okay.
And 10 times 4 is
So you do 3 as a group.
Yeah, do 3 together as a group. So Bella, maybe scoot in and take my
Okay, I got
spot.
6.
Yeah. Good. And we'll see. Liam, are you ready to do 3 with them?
I am.
Okay.
You can.
8. We gotta rest up
So since we're doing it this way, you'd have to do 10
It's cold out here.
times 12.
So for that way, they're just having you add what's in the parentheses before you multiply it.
Oh.
So what you would write right there would be 10 times, what is
8.
that, 12 minus 4? 8?
I got
So wouldn't we have to
So that's what you would write.
12 minus 4, which is 8, and then times that
And
by
then you would
10,
do 10 times 8.
which is 80. Like that?
Yeah.
Wait, is it like this? So
See the examples right there that you guys can refer to, but what they're wanting you to do is add or subtract what's in the parentheses first and then multiply that number.
like this. Alright.
Boom.
So for that side, it's a little different because we're breaking it like this, you know?
I messed.
Okay, let's see. Can I use somebody's eraser? Thank you. Let's erase this really quick too so we can do it. Okay, so for this side, sorry Liam. For this side, we're gonna subtract this first. So 12 minus 4.
12 minus 4 is... Oh.
Close. So that's 8. And then we are gonna multiply it by 10. 10 times 8, and that's your answer. So for this one, how we're gonna do it is more like breaking it apart. So it's gonna say 10, so you're gonna start with 10, and then you would multiply that by 12, so write that, by 12, and then minus, no, this number again, because we're gonna distribute it to that, 10 times 4.
Oh.
Because remember, we're kind of going like that. So what's 10 times 12?
10 times 12, 120.
Yep. And then minus what's 10 times 4?
40.
Mm-hmm. We're subtracting. Okay guys, today we're gonna do a packet in Math Antics on the distributive property. Okay? First we're gonna watch a video. While we're watching the video, can you guys all take notes so you can use that for your packet?
Okay.
Okay. Adrian, do you want to turn the lights off?
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to talk about a really important math concept called the distributive property. Well, at least that's what it's called sometimes. You may hear it referred to as the distributive law, or even the distributive property of multiplication over addition, by people who want to sound really technical. But no matter what it's called, the concept of the distributive property is the same. Before we actually dive into that concept, there are two quick things that will help make it easier to understand. The first is simply knowing what the word distribute means. To distribute something means to give it to each member of a group, like an old-fashioned paperboy delivering newspapers to each house in a neighborhood. One for you. One for you. Oh, just sorry. One for you. And one for you. The second thing you need to know is the order of operations rules of arithmetic, which we cover in another video, so you might want to watch that if you're not familiar with those rules already. That's because the distributive property is actually a way of allowing us to change the order of operations we do in certain types of problems. To see what I mean, have a look at this simple arithmetic expression, 3 times the group 4 plus 6. We're going to simplify this expression in two different ways. The first way, we just use the basic order of operations rules that you already know. But the second way, we use the distributive property. And if we do the arithmetic right, both ways will give us the same answer. So for the first way, our order of operations rules tell us that we need to do any operations inside of groups first. And since these parentheses form a group, we first need to add the 4 and 6, which gives us 10. Next, we can multiply that by 3, which gives us the final answer of 30. Now, let's use the distributive property. The distributive property allows us to change this expression into a different form. Instead of multiplying 3 by the whole group at once, we can distribute that factor of 3 and multiply it by each member of the group individually. That means we'll make a copy of the 3 times for each member of the group, the 4 and the 6. So after applying the distributive property, our expression looks like this: 3 times 4 plus 3 times 6. Because we distributed the multiplication to each member of the group isn't needed anymore, so the parentheses can go away. Now, we can continue to simplify this new form using our order of operations rules. Those rules tell us to do multiplication before addition. So, 3 times 4 is 12, and 3 times 6 is 18. The last step is to add those two results together. 12 plus 18 equals 30. Well, look at that. We got the same answer in both cases, which means our original expressions are equivalent, even though they have different forms. In the first form, the factor 3 is being multiplied by the entire group all at once. So we needed to do the addition inside that group first. But in the second form, we use the distributive property to rearrange the expression so that the factor of 3 is multiplied by each member of the group individually instead of the whole group all at once. Distributing that factor made the group go away, so we didn't have to do the addition inside that group first. So the distributive property is basically a way of getting rid of a group that is being multiplied by a factor. If you distribute the factor to each member of the group, you'll get the same answer you would if you calculate what's in the group first and then multiply. And it works no matter how many members are in the group. Like in this problem, we have to multiply 4 by the group 1 plus 2 plus 3. Again, let's try simplifying this both ways. In the first way, we start by simplifying what's in the group. 1 plus 2 plus 3 equals 6. And then we multiply 4 times 6, which gives us 24. Now, let's use the distributive property. We distribute a factor of 4 to each member of the group, which makes the group go away and allows us to do those multiplications individually. 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. Finally, we add up those three individual answers. 4 plus 8 is 12, and 12 plus 12 is 24. See, the distributive property gave us another way to arrive at the same answer. It's like the distributive property is an alternate path that you can take to arrive at the same point.
What are you doing here? I'm always here.
Okay, great. We have two ways to get to the same answer. But why do we need two different ways to do the same calculation? And it seemed like the distributive property way was even more complicated than the regular way. Why would we ever want to use it? That's a good question, and it's true. There are times when the distributive property way is harder, like in our first problem. It was easier to just go ahead and simplify the group first because it's easy to multiply 3 times 10 mentally. But there are also times when the distributive property way is easier, like in this case, 8 times the group 50 plus 3. If we decide to simplify the group first in this problem, we end up needing to multiply 8 times 53, which is not so easy to do mentally. But if we apply the distributive property instead, we can change the expression into 8 times 50 plus 8 times 3, and that's easier to do mentally. 8 times 50 is 400, and 8 times 3 is 24. So the answer is 424. Realizing that the distributive property can make some calculations easier to do mentally can come in really handy for certain basic multi-digit multiplication problems. That's because you can break up the multi-digit factor into a group sum, like expanded form, and then distribute the other factor to the members of that group. Sound confusing? Here's what I mean. Let's say you need to multiply 5 times 47. Well, you could just use the multi-digit multiplication procedure, or you could change this into a problem where the distributive property will make it a little easier to do. The key is to realize that you can replace the 47 with 40 plus 7. Then the problem becomes 5 times the group 40 plus 7. And the distributive property lets us change that into 5 times 40 plus 5 times 7. Those two multiplications are easy to do. 5 times 40 is 200, and 5 times 7 is 35. So our answer is 200 plus 35, or 235. Want to see another example? Let's apply that same idea to this multiplication problem. 3 times 127. But instead of 127, let's change that into the group 100 plus 20 plus 7. We need to multiply that by 3, and the distributive property lets us distribute that multiplication to each member of the group. 3 times 100 plus 3 times 20 plus 3 times 7. That helps because we can do those mentally. 3 times 100 is 300. 3 times 20 is 60. And 3 times 7 is 21. All that's left to do is add those three products up, which is not too hard to do mentally either. 300 plus 60 plus 21 gives us 381 as our final answer. Now, before we wrap up, there's one more important thing that you should know about the distributive property. You already know that the distributive property works when the members of a group are being added. But it works the same way for members of a group that are being subtracted, like in this problem. 7 times the group 10 minus 4. You could do this problem the typical way and simplify the group first. 10 minus 4 is 6, and then 7 times 6 gives us 42. Or you could use the distributive property. You distribute the 7 times to both members of the group to get 7 times 10 minus 7 times 4. 7 times 10 equals 70, and 7 times 4 is 28. And 70 minus 28 equals 42. Again, both ways are equivalent. So the distributive property works for groups of any size, and it works the same for group members that are being added or subtracted, even if there's a mixture of addition and subtraction in the group. But the distributive property doesn't work when the members of a group are being multiplied or divided. For example, if you have 5 times the group 2 times 3, you can't distribute a copy of the factor 5 to each member of the group without getting a completely different answer. And the same goes for division. If the members of a group are being divided, like 4 times the group 6 divided by 2, you will not get the right answer if you distribute the factor 4 to each member. That's why the technical name is the distributive property of multiplication over addition. You're distributing the multiplication over all of the members of a group that are being added. And the reason that it also works for subtraction is that subtraction is really just a negative form of addition, since subtraction and addition are inverse operations. Alright, so the distributive property is a handy way to rearrange arithmetic expressions. It's like a tool that you can use in certain situations if you think it will make a particular calculation easier to do. And even if you don't end up using the distributive property a whole lot for arithmetic problems, it's still a really important math concept that will be even more useful when you get to algebra. Until then, be sure to practice what you've learned in this video by trying some of the exercise problems. Practice is the best way to make sure that you really understand. As always, thanks for watching Math Antics, and I'll see you next time. Look.
It's a good note. Was that pretty simple, you guys? Think you can do that?
Yeah, easy.
Yeah? Okay, before we break off into small groups, let's do some examples together, okay? Can you guys see that? Yes. Yeah? Okay. Okay, number 1. Does anybody want to do this? Okay. What would you do first? 4 plus 2 is 6. Let's do it like the way that they're teaching us to do it. So we're going to go 8 times 2. What is that?
16.
16. And then 8 times 4. 32. Then let's add both of those. And what's our final answer? 48.
Did you think?
You see, that's how they were kind of explaining it in the video, more to break it down. Because in this packet we're doing, we want to show all of our work on these papers. So we're going to need to break it fully down to get the full credit. Okay? Let's do number 2. Does anybody want to do it? Logan? Okay.
3 times 6 is 18.
Yep. And then
And 3 times 1 is 3.
there's 3. Then we add those. And what's your final answer?
21.
21. Anybody want to do number 3? This is a little, yeah, Cody?
2 times 5 is 10. 2
And
times 6 is 12. 2 times 7 is 14.
2 times 7 is 14. Then we add all those up. And what's your final answer?
36.
36. Yeah. Okay, 2 more before we start. 3 times 7. 3 times 4. Add those up. 33. This one is a subtraction one, so what would we do first? What's that?
60.
Is it 60? Yeah. 5 times 6? 30. Then we would subtract it. So what's our answer? 30. Okay, good job. I think you guys can do it.
Easy.
Okay, so we're going to break off into small groups. Yeah, you can pass these out. Yeah, I'll leave this on the board for an example. Also in the packet on each page, the first one is an example to help you guys out. We're going to work in small groups, so if you have any questions, you can come ask. And when you're done with the packet, there's going to be on the back counter keys for you to grade it. So if you miss 3 on each page, come grade it, and then come talk to me, and we'll go through it and explain it a little better, okay? Sounds good?